first thing I was right on. The whole question then wants me to find what the weight of that bar is, and it says it's held in equilibrium, so AB is in equilibrium because of this pulling, okay? So I can clearly see that's 30 degrees, and they've helped you out here because they've put on that vertical line. So they're showing you, technically, you want to find out what that force is at that perpendicular distance. Okay? So if I look at my string and I follow it through, the tension in that string is going to be equal to the weight because it's held in equilibrium. I know weight is equal to mass times gravity, so what I have to use is my 2 and multiply by 9.81. So clearly, my weight here is 19.62. So my tension here is 19.62, and it goes through the pulley. So again, my tension here is 19.62. So I want to find what the vertical is. So I take the tension and I go through the angle. That's going to give me my vertical. So to go through the angle to cosine. That's 19.62 cosine 30 is what that perpendicular is, right? I want to find the weight is, but I don't know anything about B. So I'm going to take moments about B so I can put the B more. So I'm going to write that for myself. I'm going to take moments about B so I can ignore any of those forces at B. So I put my finger there, and I can see I've got a moment going in the anti-clockwise direction due to weight. So I know that the weight multiplied by 0.8 is going to equal the moment in the clockwise direction, which is my 19.62 cosine 30 times the distance from B, which is 1.6. So in order to find what the weight is, all I have to do is 19.62 multiplied by cosine 30. Then I have to multiply that by 1.6. And I have to divide that by 0.8. So I figure the weight of my beam there, W, is equal to 33.98 newtons. So, it's grand. Hey guys, what's the crack? So what we're going to look at now is the moments using the pulley, okay? So what we've got here is a uniform bar AB. So straight away, when I see uniform, I know what that means is the center of mass, or its weight, we take in the middle, right? So its midpoint is where its weight is going to act. It's only at 1.6 meters long. So that weight there is going to be 0.8 meters away from B, or 0.8 meters away from A, wherever you want to do it. Okay, so it's the first thing I was right on. The whole question then wants me to find what the weight of that bar is, and it says it's held in equilibrium, so AB is in equilibrium because of this pulling, okay? So I can clearly see that's 30 degrees, and they've helped you out here because they've put on that vertical line. So they're showing you, technically, you want to find out what that force is at that perpendicular distance. Okay, so if I look at my string and I follow it through, the tension in that string is going to be equal to the weight because it's held in equilibrium. I know weight is equal to mass times gravity,